Welcome to session 17 of my ozone technology course. This session will be dealing with application of ozone in potable water and its advantages over the chemical treatment. Before I proceed to ozone application for potable water, it is necessary for me to address another common treatment with UV ozone technology. We can also produce ozone using UV. UV is a very high frequency wavelength that has sufficient energy to activate the oxygen molecule, dissociate it, and recombine to form ozone. In other words, the oxygen in the air or oxygen itself, when it is passed through the UV at a specific wavelength of 294 millimicrons, will be activated to form ozone. This method is used to generate ozone but can be used in rather limited applications such as air and sewage pre-tree ozonation treatment because of the very low concentration of ozone so produced. Ozone is produced when oxygen or air is passed through the UV light at 295 microns. As the air or oxygen passes through the lamp, the UV will break down the oxygen to atoms and recombine to form ozone. This diagram is a picture of an ozone generator that is used to treat the air. Simply, a fan is on this end of the picture, which sucks in air and blows through the lamp, and then out comes through the gills to treat the air. The amount of ozone depends on the strength of the UV rays and the flow rate of the feed gas. The limitations are the rate of production of ozone by UV per tube is very low, and therefore the concentration is low. A typical UV system will contain several U-tubes to give higher production rate and increase the concentration. The issue is when air passes through the lamp, it contains dust, slime, etc., and it may coat the side of the lamp and prevent the UV or block the UV coming into the air to convert the oxygen to ozone. So it is necessary to very frequently clean the surface of the lamp to ensure it is totally clean. This is a picture or diagram which shows an equipment that produces ozone by passing air through the UV lamp. So the air that goes into this tube inlet passes through the UV lamp, and the UV lamp that generates ozone, and the oxygen is converted to ozone, and the ozone air mixture will come down and through this into the venturi, where it is sucked. The water from the swimming pool or water treatment, drinking water, is sucked in through the venturi, pumped in through the venturi, and the ozone bubbles will eventually dissolve in the water and do the sterilization, and the water that comes out will be free from microorganisms. This particular equipment is used for water treatment rather than air treatment, and it can be used for small swimming pools or spas. The disadvantages in application for ozone treatment using UV. The water must be very clear without any particulates, as they also can deflect the UV rays and reduce the contact with the flowing water. There must be multiple tubes to increase the ozone output and contact time as well as flow rates. There are certain parameters of water in the water that we should consider when we apply ozone for the treatment. They are the particulate matter, dissolved solids, total organic content, total inorganic content, the biological oxygen demand, and chemical oxygen demand. We are going to discuss the disadvantages of the chemical treatments of water compared to ozone treatment. The chemical treatment will generally not remove soluble organics, but you could do that by flocculating the water using expensive chemicals, and there will be a time expense too for the chemicals to be reacting and for the settling and the removal of the sludge following the settlement, and allowing the treated water, clear water, to go through for filtration. With ozone treatment, however, the treatment with ozone itself will flocculate all soluble organics, either causing it as precipitation and removed by filtration, or will react with very small organic compounds to form carbon dioxide and water. In chemical treatment, the removal is generally not complete. Also, killing of the bacteria is also not complete. About 99.99% of the bacteria is eliminated by chlorine, and the residual 0.01 or 0.001 percentage of the bacteria will lay dormant until the effect of the chemicals, that is chlorine, are reduced. Then these bacteria that have survived will begin to multiply using the soluble organics, which has not been removed by any chemicals, as food, and the water will become stale and unusable. Chemicals do not destroy virus. Chemicals are not strong enough for the concentration that apply to kill cysts, whereas ozone will destroy virus because of the effect it has got on the RNA and the DNA, and most cysts can be killed by normal ozonation, but some, like Cryptosporidium and Giardia, will require a higher concentration of ozone and chlorine combination. The other disadvantage of chemical treatment system is to set up the chemical treatment, you need a capital cost, dosing, tanks, etc. And then you have a forever recurring and ever increasing chemical consumption cost. However, with ozone treatment, you find that there's only one capital cost, which some manufacturers or some organization may be able to provide finance for, and a very low electrical consumption cost and virtually zero other consumption, chemical consumptions. Chemical application requires increased time of process, often with a spillover of the application chemicals into the treated water. Since ozonation doesn't require any chemicals, the treated water will be free of chemicals. Effect of ozone on particulate matter. As you know, the particulate matter are generally many insolubles which can be easily filtered off, and otherwise, if they escape the filter, the ozone will react with the organic particulate matter and break down to simpler organics if sufficiently exposed. So we would suggest filtration would be a more effective and faster process. The effect of ozone on total dissolved solids, on chemical oxygen demand for inorganics, or that's COD, and the BOD is the biological oxygen demand of dissolved organics, and total organic content, or TOC. Ozone will react with oxidizable dissolved chemicals such as iron, heavy metals, etc. Soluble sodium and potassium salts are not reacted with, and they remain if they are in solution. The heavy metals, iron, etc., zinc, etc., will precipitate out for filtration. Ozone will react with almost all dissolved organics, some sugars and small molecules of sugars accepted. It denatures the proteins by changing the nature of the protein and therefore its solubility, and resulting in the flocculation and removal by filtration. The effect of the biological demand, oxygen demand. Ozone will reduce the BOD to nearly zero. Natural water has very low BOD, typically because of dilution, and can be eaten, whatever that is there can be totally removed by ozone. Chemical treatment, on the other hand, can produce the same results but with very high cost and time. The effect of ozone on chemical oxygen demand, by the definition of COD, or chemical oxidation demand, it indicates that it is oxidizable, and therefore ozone will reduce the COD by oxidizing all the chemicals that can be oxidized because of its very powerful oxidative capacity. We will be able to obtain near zero depending on the starting concentration and depending on the length of time there is an ozone reaction and concentration of ozone that is used to react. In the case of chemical treatment, we will probably achieve the same results, but we need very high amount of quality chemicals and cost of time, and there will be a high degree of environmental pollution because of the sludge. Ozone demand. The definition of ozone demand is the amount of ozone that is required for the complete oxidation of BOD, COD and TOC. We use this to calculate the amount of ozone required for any specific treatment. Obviously, the ozone demand will be the sum total of the BOD and COD. I want to recall and water treatment I introduced in India the first time. I brought into India a disassembled ozone generator and assembled the ozone generator in Chennai. I got a 500-liter drum. I had with me a venturi. I obtained a treatment pump and the plumbing materials, and I set up a very simple ozone treatment. The ozone generator was a simple small ozone generator that had a fan that will suck the air and treatment. Conversion of the air into ozone and is sucked into the venturi. As the water flows and recycles, ozone continues to react until the redox level here had indicated 700 plus, which gives me the information that the water is sterile. At 700 plus, the bacteria cannot survive. So we try to ensure that redox levels exceed 750 millivolts when we complete the treatment. This water, which was previously undrinkable, I showed by example that I could drink it, and the people were so happy and agreed to form a company called Ozone Technology Systems and Proprietary Limited, or Private Limited. And this system was used to provide water, cheap water, for the local community. There are two types of treatments of potable water for a simple water treatment factory or community treatment or council treatment, etc. The first one is the batch treatment process. As I did explain in the previous slide, I started with one tank and recirculated to obtain treated water, and that water can be used and fresh water added, treated again. This way we are getting treated water in batches. Here is an improved version of that, where there are two tanks involved, so that while one tank gets treated, water is filled into the other tank, and by the time the water is topped up in this tank, the treatment will be completed in this tank, and treated ozone treated water will be taken through the two-way valves for consumption. And when this is emptied, water fills in again, new water fills in again, and the treatment now proceeds with this tank while this is filling, and by the time this is filled, this water in the tank is treated and it can be used, followed by refilling of this tank. So by alternating the use of the tanks, we might be able to produce continuous treated water for the factory at a considerable cheaper rate. This process of treating potable water with ozone is a continuous inline process which is used for very, very large water treatment, council water treatment systems. You have a compressed air feed to the ozone generator which generates the ozone, and the ozone gas comes through into the venturi. The raw water after filtration comes through, and there is a bifurcation where one small amount of water is sucked in through the feed pump, small ozone feed pump that feeds this venturi to cause the vacuum and ozone solubility. The ozone water mixture goes and joins up with the other water and goes into the contact chamber. The flow rate of the water in this pipe is very, very much faster than the flow rate of the water in this contact chamber. Therefore, the ozone that is already pumped in the water here would have sufficient time to be absorbed by the water, and by the time the water comes to the top, it is totally treated. Of course, we have to ensure that the ozone generator produces enough ozone to give us a concentration that will ensure the total concentration is in the concentration that will ensure complete sanitization or bacterial removal. The concentration of ozone can be measured, dissolved ozone can be measured using the dissolved ozone meter, and we would be able to measure as to how much of the ozone is in the returning water. That will allow us to know that how much of ozone is in the water and how effective the treatment of the water is. The ozone that is not dissolved will be taken in as a gas, and this unit is an ozone destructor, so it will break down the ozone to oxygen. So the ozonized water can be either taken straight for distribution, or in the case of factories, it might be having a buffer tanks from which the water can be pumped in, filtered, and used in the factory. Now, if the water is directly used for community purposes, then obviously it is further added with chlorine and ammonia to ensure all the distribution channels are clean and that water will have sufficient residual chlorine till it comes out to the tap. In summary, we have a primary filtration of the raw water from stones, etc., twigs, stones, etc. Then we feed the ozone through the venturi at the concentration of the injected point calculated for a total ozone content for whichever the volume flow or total volume in the case of a factory requirements. The atomization of the ozone gas in the venturi induces greater solubility of ozone. The contact chamber, which allows or slows down the flow rate of the water to provide an optimum contact time to ensure the maximum transfer of ozone into the water. Any residual gas that has not dissolved in the water is vented off through the ozone destructor and converted to oxygen. The ozonated water can be diverted to a closed tank and used for redistribution after treating with the secondary disinfectants such as ammonia and chlorine to allow the water to retain its disinfection until it reaches the pipes, or it is diverted from the closed tank, particularly in a factory, through another pump and to a secondary filter. The water filtered off precipitates from flocculation caused by the ozone reaction, and it can be used in the factory. We have come to the end of this session, session 17. Thank you very much for those who have had the patience to listen to this session. Please go to the next session, session 18, which will deal with ozone application for sewage treatment. If this is your first tune-in, please visit sessions 1 and 2, which gives the program details, and 3 to 16, sessions 3 to 16, which with more sessions in ozone technology course. Please click that like icon or the subscribe icon, and you will be notified of the next session as soon as it is uploaded. Thank you and have a very good day.